Hello everyone, welcome back to ConArchy YouTube channel. In our previous video, we modeled and analyzed a simply supported beam where we generated our shear force diagram and our bending moment diagram. So in this video, we are going to do exactly the same thing, but the only difference is that in this model, we have a UDL here and also a varying distributed load over here. I'm going to teach you exactly how you are going to model these types of loads. So let's get started. So first of all, you have to open your Etabs app. Then you go to new model. So this is a new model we are going to be doing. So you click on new model, and per the settings you'll be using in your design. So I'm going to select use built-in settings. These are my settings I'll be using, my code and the unit of measurement. So just click on OK. If yours is not selected, you have to select it before starting the design. So right now, all we have to do now is to set our grid lines. So number of grid lines in X direction and Y direction. Let's go back to our drawing. So in this drawing, we have our first grid line cutting through this support, our second grid line cutting through this support, that's our second one, and this is our third grid line cutting through this last part of the beam. So in the X direction, we have three grid lines that are cutting through them. So let's go back to our app and input 3 into the number of grid lines in X direction. And in our Y direction, just like the previous one, there's just one grid line in the Y direction. So spacing of grids in X direction, we have first grid line spacing 40 plus 10 plus 20. We have 70. And this is our second grid line spacing. We have 50 plus 20, that's also 70. So we can input the spacing in X direction to be 70. So within each grid line, the spacing is 70 meters, and spacing in the Y direction is just one. There's no spacing, you just only have one grid line, so you can't get a spacing. So in the case your spacing is not uniform, is different, you also have 60 or another form of measurement. You have to come to custom grid spacing, come to edit grid data. So first of all, we have display grid data as ordinates. As for this one, we have our grid ID A. So we are starting at our first point is 0. The distance here is 0. So this is our second grid line. The distance from here to our second grid line is 70. So just like it's here, 70. And our distance from the first end to the last point is 70 plus 70. So we have 140. So 140 here. So that's what is meant by the display grid data as ordinates. So this option displays the data as spacing. When in this option, it displays as a spacing between this grid line and this grid line. So we have 70 meters at this. We have a 70 meter span here, and we also have another 70 meters. So our spacing is 70. So in the case this place was supposed to be 60 and this place was 70, all you have to do is input 60 here and also 70 there. They have different measurements but of the same model. So once you are done specifying, you just have to click on OK. And we have a number of stories, just like the model we first did is just 1. Typical story height. I'm just going to leave everything like that. And once you are done, you select grid only, then click on OK. So this is how it looks like. We have a plan view here and our 3D view. But like we are going to be working in the elevation view, so let's change this view to the elevation. So 1 and apply. So this is how it's going to look like. The distance here is very small. it makes working like you can't really see the difference between this grid line and the one at the down part. So let's try to increase the height here. So this is a story. Let's increase the story height. All you have to do is go to edit, and we are going to edit story and grid system. So this is the story. I'm going to modify show story data, and this is the story 1. We have story 1 here, and this is the height. Let's try to increase the height to say 10, and click on OK and OK. Now the height has increased a bit. At least you can see the difference between the first one and the second one. So let's start with our model. So first of all, we know we have a point load 20 meters from the pin support. So we are going to apply. Oh, sorry about that. We will need to draw our beam first. We don't have our beam on the grid line. So let's first of all draw our beam. So let's pick this quick draw beam option. So click on quick draw beam since it's very fast. Then click here too. And now we have our beam. Then press on escape on your keyboard. So we are going to assign that 4 kilonewton load, point load, 20 meters from the first support. So we are going to select this beam. They are separate beams. When you select this one, it doesn't select. There are two separate beams because we drew them separately. So you select this beam, go to assign. It's a frame load and it's a point load. So point load, let me shift it so you look at it very well. So we have relative distance from end. In this option, let's see where our load is. Our load is 20. We are going to consider this beam. Our load is 20 meters from the first support. So as for this option, the relative distance is in the form of a fraction. So we are going to, this is the full length of the beam. The full length is 70 and the distance here is 20. So it's in a fraction form as in 20 over 70. So for that you get 0.286. So sometimes it doesn't really give you an exact value. There are decimals there. That's why I prefer to use the absolute distance where you specify the actual distance there. So for that one, for the relative distance, you just specify that decimal you got here, that was 0.286. You are just going to input that here and input the load, and it will just go to the place you want the load to be. But let's use as usual our absolute distance from end. The distance is 20 meters, and the load there we know is 4 kilonewton. Yeah, 4 kilonewton. So we are just going to apply, it's a gravity, it's in the gravity direction, it's a force. We are going to assume it's a dead load, and let's replace existing loads here. So let's apply, and now we have our 4 kilonewton load, 20 meters from the first support. What load do we have again? We have a UDL here, and for this UDL, it's a 5 kilonewton per meter UDL, and it starts at a distance of 30 meters from the first support. So let's go back to let's close this one, because this one we are applying a frame load. That's a point load. So this is a point load dialog box. We are going to open the UDL. So assign and go to frame loads. This is a distributed load, so click on the distributed, and also it's a force gravity. Let's go to add to existing load, absolute distance from end, and we know that it starts at a distance of 30 meters from the first support, so 30, and the load is 5 kilonewton, and it ends at a distance of 70 for that beam. So 70, and it's also 5. So apply. Yes, first of all, before you apply the load, we all know that you are supposed to select the beam you are applying the load to. So once I've selected it, I can now apply to it, and then we have our UDL on our beam. So we click on OK. What other load do we have? Now we have our varying distributed load here. I'm going to teach you how to apply that one too, and it's on the second beam. It's on this second beam 20 meters from here. So let's assign that one too. We're going to assign to this frame, so you select assign frame load. It's also a distributed load, but it's varying. So everything is set. So replace this frame here, absolute distance. So at a distance of 20 meters, we have the load there to be 0. 20 meters, we have 0 load there, and it's going to vary till the 70 meter where we will get our 5 kilonewton load. So at a distance of 70, we have our 5 kilonewton per meter load. Everything is set, our frame is selected, so we just apply, and then we have our varying distributed load. What else do we have remaining? Now we have to put our supports here, our pin and our roller. So we are going to select these grid points, assign joints, restraints. We have our pin supports here, apply. We now have our pin support there, and we are going to select. It's normal if your loads are not there. They are there, but they are not showing. Since I'm considering supports now here, and I'm going to apply my ruler. This is the ruler supports, then apply to that point, then OK. So now everything is intact and I'm done with everything. So all I have to do is analyze, check model, select, then OK. So model has been checked, no warning messages were generated. So we are going to run analysis, but we know that our beam here also has its own self rate, and we are going to send the self rate of that beam to 0, since we will not be analyzing the self rate too. So we are going to assign frame property modifiers, and we are going to send the mass and the weight to 0, just like the previous video what we did. So apply, then OK. So this is it. So once we are done, we'll run our analysis. So I have to save this. Let's save it as UDL and VDL. Any name you prefer, you can just save it like that. So save, and the model is being analyzed. So the analysis is being done. It's going to analyze this beam and generate the shear force, the bending moment diagram, and we are going to see how this beam will deflect under the loads. So just look at it right here. Our analysis was done on this window. Let's look at it again. So this is how the beam is going. I'm going to show you in the elevation view so you can see it perfectly. Applied and OK. So this is how the beam is going to deflect our varying distributed load at the edge of the overhanging beam. Since there's no support here, it's going to deflect very much down. And let's check for the reactions at the supports. We have our reactions at the supports. These reactions are due to the loads only, not the self weight of the beam. So close, and let's look at our bending moment and shear force. For our bending moment and shear force, so shear force 22, show values at control station, apply. So this is how our shear force and bending shear force looks like. let's go to the moment 3-3 and apply. So this is how our bending moment also looks like. So that's it for today's video. If you enjoyed the video, don't forget to like and subscribe. Thank you very much for watching. See you.